Alrighty, so in this video what we're going to start off doing is getting a stub together of all the classes that I want to use to put this whole example together and show you guys the basics of how you interact with the Roslyn syntax tree, and also get a quick feedback loop going. What I mean by that is for my buzzmmo.tools project, I want to be able to run this as we're building it up and make sure that we're on the right track, get some quick feedback for testing. I'm not going to be unit testing any of this, and the reason I'm not unit testing this is unit testing code generation is actually a very tedious thing, so we're just going to go with the really quick and dirty route of setting up a test harness, quote unquote, a sort of system that we can quickly iterate on, at least see the output of what our generator is doing as we work forward. But before we do that, I want to go ahead and get our basic classes involved. So we're basically going to be having 3 files. We'll have a couple more classes than that, but we're going to have 3 major files, 3 sort of layers, I guess you could say. And I'll go ahead and start that off by creating a new namespace here, and I'm going to call it proxy generator. I just want to keep all the proxy generator things inside of this project here. And so the 3 levels that we need is, the first thing we need to do is analyze the syntax. So what I'm going to say is I'm going to say proxy syntax analyzer. So we'll come back to this guy here pretty soon, but what this layer is responsible for is it's responsible for actually taking the abstract syntax tree of the C# compiler and turning it into a format, or abstracting or extracting the data that we want out of that C# file. Next up, we're going to go ahead and we need, on that note, we're going to need a proxy component. Now, the proxy component class, we're going to have a couple other classes, nested classes within here. The proxy component, you can think of as a sort of model, an in-memory representation of what the proxy syntax analyzer found. In fact, you can think of it as this class being the output of this class. So we have our proxy component, which is, the information about the component that was gathered by the syntax analyzer. Now, it's not going to be nearly as detailed as a component map, and unfortunately, that's just something we're going to have to live with. There's no way around that. The whole reason that I think the solution that I came up with works better than the previous solution is because it doesn't require us to load the buzz.mmo or buzzmmo.base project or assembly into our app domain, which causes so many problems. So since this doesn't require us to load that assembly into the app domain, we therefore have much less information to work on. And that's what this proxy component is going to encapsulate. Now, the final layer of this whole project is going to be our, of course, proxy code generator. Now, the proxy code generator, you can think of the proxy component as being the input to the proxy code generator. The proxy code generator is simply responsible for generating the code based off what the proxy syntax analyzer sent to it. All right, so with all that out of the way, I do want to go ahead and stub these classes out, starting on the proxy syntax analyzer, but I won't be able to do that until we talk a little bit about Roslyn, but most importantly, get it installed. So Roslyn is currently distributed on NuGet as a pre-release package, but again, don't let that scare you because it's pretty much done, and it's going to be pretty much, and besides, we're using so little of the API, even if it does change, it won't be that big of a deal. Roslyn, like I said, has been around for like 4 years, or at least in the open source world for about 4 years, and it's very, very mature. In fact, I do believe that Visual Studio 15 is mostly all the IntelliSense and refactorings and everything is built around Roslyn. So it's perfectly stable to go ahead and use in production. So the way that we're going to install it here is I'm going to open up my Package Manager console. Now, if you don't have your Package Manager console open, you can access it by going up here to Tools and jumping down to NuGet Package Manager and opening up the Package Manager console. Now, the reason we need this is because we're installing a pre-release package. Then here I'm going to say install-package, and I'm going to say code analysis .c# -pre, and I'm going to hit enter. And that's just going to go ahead and pull down all of the DLLs that we need to work with what we need to for. That was a horrible sentence. It's just going to pull down what we need. Basically, it's just going to pull down. We can look at what it pulled down by opening up our packages, or not, I guess. Oh, What's funny is I was going to make a note of this, like in the video I saw that, then I totally forgot about it. So just let this be a lesson to everyone. When you have your package manager console open, the project that it's referring to is going to be the default project. As you see right here, it's pointing to buzzmmo.web. So we, of course, want to switch that over to buzzmmo.tools, and we want to repeat this installation. So I'll just hit the up arrow and hit enter. Okay, so I'll take a look at the packages that it added, but first I'm going to go ahead and remove them from BuzzMMO Web, because we don't need them there. So I'm going to come up here. It should show up in my installed packages. So I just need Microsoft.code analysis. Where are you? C# uninstall. And it'll ask me to uninstall all the other packages that depended on it, which I want to say yes. And that'll just undo that terrible, terrible mistake I just made in a moment. There we go. Okay, so the packages it brought in, we can see by opening up our packages.config, and we see it brought in the immutable collection, some reflection stuff. It brought in our code analysis analyzers, common, and C#. Okay, so now why did we need to pull that package in if we're just stubbing things out? Well, the reason for that is the way that the most appropriate way to actually navigate an abstract syntax tree in Roslyn is to create a syntax walker. And we do that by creating a class and having it inherit from a syntax walker. So there's a handy one here called the C# syntax walker. C# syntax walker. And it comes up like that. So you see that there aren't any required or abstract methods on it. But what's interesting about this class that I just inherited from, if I hit Alt-Insert-O, we will see all of the methods we can override, all the methods available on the base type. You'll notice there's a visit for virtually everything in the C# language. So for example, let's say I wanted to collect all namespaces. So I could do visit namespace declaration. Or let's say I wanted to visit all expressions. I can visit assignment expressions, I can visit literal expressions, type of expressions, size of expressions. So I can really just mix and match what I want to visit based off what nodes I'm interested in, based off what I override here. So, for example, in what we're going to be writing, there's a handful of things that we're going to need to visit. We're going to need to visit namespaces. So I'm going to say visit namespace declaration. I'm going to hit space on that to override that method. We're also going to need using directives, not using statements. You'll notice they're using statements and directives. Using directives are the things that appear up at the top of the file. Using statements are the things that you use to deterministically release resource or unmanaged resources. For example, using file stream or something like that. So we want the visit using directive here. We're also going to need interface declaration. I'm sure you saw that one coming. And we're also going to need class declaration. The reason why we need class declaration is I'm going to support component interfaces being nested interfaces within classes. Now I'm going to hit finish. Now if you don't have ReSharper installed, don't worry. Basically you can take all the code that just appeared on my screen and just copy it down. I do think there's also a way to do that natively in Visual Studio, but I forgot the shortcut. Anyway, you just want to override visit namespace declaration, visit using directive, visit interface declaration, and visit class declaration. So just grab all those overrides, and of course we'll fill them in later. Then next up, since I do want to go ahead and have this completely stubbed out, at least all the redundant, annoying things stubbed out, let's start off with our fields. So I'm going to do private read-only IEnumerable of string, and I'm going to call this using directives. And then we're going to keep track of all the using directives of the file, if you haven't seen that. So next up, we're going to do IEnumerable of string component attributes. What are these? Well, the component attributes is, remember how I said one of the parameters to our generate method is going to be the attribute that constitutes a component in our system. For example, our component interface, like that, for example. So we need a list of those accepted attributes inside of our syntax analyzer. And we're also going to need... Why am I doing IEnumerable? I am ridiculous. Attributes should be an IEnumerable. Using directives should be a stack. Sorry. Stack of string. All right, so hopefully you guys can fix that. And then we're going to need a... whoops, not a stack, a hash set. Why am I getting all my types confused? What we need a stack of, we do need a stack of string, and these are going to be, this is going to be called the namespace stack. And this private variable is going to be responsible for keeping track of what namespace our interfaces appear in. So again, sorry for messing up those types so much. And the final thing we're going to need is a private read-only list of proxy component, and we're going to call this components. That should be fairly obvious. What that does is it just keeps track of all of our proxy components that we've generated so far, or at least parsed so far. Let's go ahead and just put together our constructor here real fast. Our constructor is going to take an IEnumerable of string called component attributes, which, not surprisingly, is simply going to be assigned to our component attributes field. Next up, it's going to be pretty boring. All we're going to be doing is instantiating these objects. So, so you can go ahead and do that real fast. Not that interesting or fun. And the final thing that we're going to do on our stub is create our public property. So we're going to do an IEnumerable of string using directives. Now this is an IEnumerable, and it's going to simply return using directives. And my formatting is just atrocious. I don't know what got into ReSharper lately. Next up, we want an IEnumerable of proxy component, and we'll call these components. Oops, what is going on there? Okay, so that's our stub. We have our using directives, our components, our for fields, and our constructor. So hopefully this gives you guys an idea about what this class does and how we're going to be using it, but we're not going to fill it in quite yet. Now let's jump over to our proxy component. This is going to be pretty quick and easy. So our proxy component is, I'm actually going to start off with creating a nested class. I'm going to create a nested class called parameter. Then I'm going to hit Alt Insert Inner and say int index string name string type. And then I'm going to go ahead and use Alt Inner down inner on all of these guys to generate their corresponding whatever you call them, automatic properties. Next up, we're going to say public class method. Hopefully you guys see where I'm going with this. The method is going to take in a int index, it's going to take in quite a bit actually, string name, IEnumerable of parameter, called parameters. And we're going to make sure we import IEnumerable there. And we're also going to need a mapped method return type, and we're going to call this return type. And then we also need a string return type name, and we're going to set that to null by default. Now we have all the constructor parameters in. It's pretty straightforward to come in and generate all these properties. Of course, all I'm hitting is Alt page down, inner, or Alt inner, down inner. Don't need to hit second inner, Alt page down inner, and we're done. Okay, let's go ahead and set all these to private. I'm looking really forward to read-only automatic properties coming here in C#6. And I guess you guys can take a look at that while something is going on. I'll close that out. Okay, so that's our method, that's our parameter, and then finally we need our actual proxy component. So our proxy component we're going to create just in the same fashion. I'm going to say string namespace name, and IEnumerable of method methods. Now for our name, we're going to, and our namespace name and our methods, we're going to go ahead and just turn these into properties real fast. And we're going to make them read-only. I wish it defaulted to read-only. I'm sure there's a setting for that, I just never bothered to look. How much time I spend typing in private, I really should. We're also going to add another property to this, and we're going to call this full name. Now, since this class is immutable, I can just come down here to the constructor, and I can say full name equals namespace name plus dot plus name. So as you see, all I'm doing here is I'm making a full name combining the namespace name and name. Also, I really wish I could call that just namespace, but I can't because namespace is, of course, a keyword. All right, so let's jump now into our proxy code generator. So our proxy code generator is going to be pretty straightforward as far as its external API, because all it really needs to do is accept an analyzer and a method that takes in a stream. But let's go ahead and code out our private variables first. So I'm going to say private read-only proxy syntax analyzer, and then I'm going to also create something that's not going to seem immediately useful at first. It's going to be a private dictionary of proxy component and string, and we'll call this concrete names. Or, how about component names? All right, so then we're going to generate the constructor, and it's going to accept an analyzer, and then I'm going to say component names equals new dictionary of string and proxy component. All right. By the way, the component names, we're going to be using that to keep track of which proxy component corresponds to which randomly generated identifier that we're going to be putting together. All right, next up, I'm going to say public void generate proxies, and he's simply going to accept a stream called outstream. And that's it. That method is where we're going to be doing all the actual generation. And so that pretty much wraps up the stub here. And what I want to do now is I want to jump into my actual generate command, and I want to get this out of the way. The reason I want to get this out of the way, the reason I want to get the whole stub out of the way is so that we have a really tight feedback loop while we're working on this. Now, before I do that, well, no, we'll just leave all this code as it is. But we are going to be nuking the innards of component interface here, and we're going to replace it with this. I'm going to say var syntax and, well, whoops. First, I'm going to do the actual parameter list. The parameter list is going to be string directory, string attributes, and string output file. Now, the first thing we need to do is create our syntax analyzer. So I'm going to say syntax analyzer equals new proxy syntax analyzer, and he's going to take in attributes dot split on comma. Of course, we want to pass in a character to that. Then I'm going to say for each var file in directory dot enumerate files, passing in the directory, passing in wildcard CS as the file name filter, and passing in all directories as the search options. I'm going to say if file dot ends with .g.cs, then continue. Otherwise, I want to say syntax analyzer dot visit, and now this is where the actual parsing comes in from Roslyn. I'm going to say C# syntax tree dot parse text file dot read all text, and passing in file and then dot get root. All right, so what's going on here? All we're doing is we're looping over the directory that was passed in by whoever invoked the command. We're making sure that the C# files that we're parsing don't end in .g.cs. That's a convention for generated files in C# land, and the reason I'm doing that here is the generated files from this I want to have end with .g.cs, and I don't want it to ever generate the components based off a file that was generated from the components, if you get what I mean. I don't want the generator to reparse its output to create a result, because that would cause potential issues. So that's why I have that filter in there. Okay. Then there's this bit. So our syntax analyzer. Remember, our syntax analyzer is a C# syntax walker, and has this method on it called visit. And visit is just follows the basic visitor pattern, but we have to pass it in a tree to visit with. And we get that tree by first invoking C# syntax tree.parse tree. Now what this returns, it returns a fully parsed syntax tree of a C# file. That's literally all you have to do. It's really straightforward to parse the C# these days with Roslyn. Now, of course, this returns a syntax tree, not a node. We don't visit the tree, we visit the node. So we have to call get root on the syntax tree to get the root node, and then pass that into the visitor. And the visitor will then just start analyzing the tree. All right, the last step we have here is to actually generate stuff. So I'm going to say generator equals new proxy code generator, passing in our syntax analyzer. And then I'm going to say using var writer equals new file stream, passing in our output file as the path, passing in file mode dot create as the file mode, and then I'm simply going to say generator dot generate proxies, and then pass in writer as its stream parameter. And that's it. So now what I can do is I can actually debug my tools. But you might be wondering, so if let's say I set my tools as the default project. So I'm going to right click and say set a startup project, and then I'm going to hit F5. And what we're going to see here is it's not going to do anything. Well, in fact, it's going to do something because I guess spoiler alert, on your guys' end, is probably not going to do anything. And that's because our tools expects there to be command parameters passed in from the command line. Well, we're going to go ahead and set up a testing environment so that every time we hit F5, we will be passing in the commands that will result in our generator being invoked. So what I'm going to do is I'm going to right-click buzzmmo.tools, go all the way down to properties, and I'm going to jump into the debug tab. So you'll start off here on the application tab if you haven't done this already. And we'll jump into the debug tab. And I'll just go ahead and nuke all this stuff. And we'll just start from scratch. So we're going to pass in the command line, we're going to pass in generate component interfaces. Then for our path, we're going to pass in ... So that'll bring it out of debug, and then bin, and then tools, and then into buzzmmo.base/components, and then we're going to say space component interface for our second parameter. Remember, that's the attributes. And then for our output, I'm simply going to say generated.g.cs. Now, this will, because this is all happening relative to the actual exe file that's going to be in our binary directory, this will create the generated.g.cs file inside of the bin directory of buzzmmo.tools, but that's fine. We'll have another window open of the generated.g.cs that we can take a look at. So now let's go ahead and save that out and hit F5, and we should just get nothing at this point. And we do. No exceptions, no anything. We can, before we end this video and go on to the next one, we can go ahead and jump into our proxy syntax analyzer and put a breakpoint on visit interface declaration, hit F5, and we can actually verify to see that indeed the code is being parsed. In fact, if I came down here to my immediate window and said node.toString, look what I get. Component interface, public interface, blah, 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 blah. iCharacter select system server, void, bleh. So we are already parsing the code pretty easily. All that's left, besides integrating this new generation into our other projects, is we have to create our syntax analyzer and our proxy code generator. So I guess we'll leave you guys with that, and we'll see you in the next video.